You can put under to make it a little higher, or maybe I have something. Yeah, just hold it there like that. Maybe, wait, I know. Wait, I know. Here. Put this under it. Yes, that'll do, yes. Okay. Discriminant now. Okay, so last time, previously in maths class, we were looking at the quadratic formula. And I was saying that this part here can't be negative. Remember that? Yep. In fact, this part here is really important part, because this part can tell us how many roots we have. So for example, if this was, say, root 9, then this could be plus or minus 3, which means we have 2 answers. But if it was 0, we have plus or minus 0, which is the same thing. So that's 1 answer. And if it was root minus 9, we don't have anything. So in fact, there are no answers. Yeah? So this part here is called the discriminant. You can use a D or a delta. So I think most people here use delta, but you can use a D if you want. Okay, so we can have like this, 2 roots if delta discriminant is bigger than 0, 1 root if it's equal to 0, and no roots if it's less than 0. I think some people, most people have seen this before, right? Most people have seen this before? Yeah. We're missing Lisa, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're missing 2 people. Oh yeah. He missed his 9 o'clock class last week as well. So he's missed, we've had 2 9 o'clock classes, and he's missed both of them. I think 9 o'clock is a difficult time for him. And who else? Oh yes, okay. Huh? Yes, yeah. And here. Yeah, okay. Right, let's have a look at some examples here. So for example, if you had a quadratic like this, and I ask you how many answers does it have, you just need to calculate the discriminant, which here will be 36 minus 4, which is 32, which is positive. So here you say, therefore, it has 2 roots. So that's just the basic idea, okay? We're not trying to find the roots. We just want to know how many roots there are. Okay. Let's try something a little bit more difficult. Okay, so something a bit more difficult now. How many roots does this this quadratic have? Now this is a k. There's only one thing we know about k. What's that?
Is it a constant?
True. It's a constant, yeah. And what do we know about its value? There's one thing.
It's the same.
True. But there's something we know about what values it could be and could not be.
Yeah.
Yeah, what?
It has three
Real number.
different numbers, like big zero, small zero, and equal zero. Okay.
Can't be zero. It can't be negative.
Thank you. Yeah. I don't think I was being clear. No, k could be negative. The k here, the only thing we know about k at the moment is that k is not zero. Now, why do I know that, or how do I know that?
Zero.
Well, if it's zero, everything's zero. But more importantly, it can't be zero because then it's not a quadratic. Yeah. So my question then now is, how many roots does it have? And I don't know k, but that's all right. I don't need to know what k is to know how many roots there are.
2.
Possibly. We'll see. So discriminant is b squared minus 4ac. That would be minus 4k squared minus 4ac. That is 16k squared minus 16k squared, which equals 0. So in fact, how many roots?
1.
Yeah, 1 root. So even though you don't know what the k is, you don't need to know it. You can still know how many roots there will be. Okay. You have that? Yeah? It's okay? Yeah. Okay. Let me give you one that's a little bit more difficult. Can I go down? Yeah. How many roots does the quadratic minus k x squared plus 9 minus k x plus 3 have? So again, I'm not telling you what the k is, so you don't know exactly what the quadratic is. But again, you do know at least one thing about k. What's that? It's not 0. Again, because of this part here. So what I want everybody to try for me is I want everybody to try and find how many roots this one has. How many do you think?
2.
Anybody else get an answer?
I don't.
Did you get an answer? No?
2.
I think it might be 2. Let's have a look. Okay, can you look up? Look. Hey, hey. Look up. We'll do it now. So, discriminant is b squared, which is 9 minus k squared, minus 4, and that's the a, and that's the c. So, a, b, and c. that would be 81 minus 18k plus k squared minus 12k. Yeah?
No.
Plus.
Plus. Okay.
Plus, minus, yeah. K squared minus 6k plus 81. Now you might think,
Has it no answer?
not that it has no answer, you might think, oh, this doesn't tell me if this is positive, negative, or 0.
Yeah.
But what you could do is you could complete the square here. So you get k minus 3 squared. Then you have 81 minus 9, which is 72. And you might be thinking, well, what was the point in that? But the point was, by writing it in this form, you can see that, yes, that the discriminant equals a positive number plus a positive number. So therefore, the discriminant is positive. And could it be 0? No. So it has to be 2 roots, exactly 2 roots. So the point I'm trying to make is you don't need to get a number answer here. Sometimes it's clear from your answer if you rewrite it, if the discriminant is positive, negative, or 0. Okay. Now, let me just show you something with this one here as well. It opens. Still waiting. Still waiting. There we go. Alright, can you read the quadratic back to me? What was it? Minus k x squared
Plus
Plus
9 minus k
9 minus kx
plus
K.
plus
3.
3. So what I'm saying here is this always has 2 roots. It doesn't matter what the value of k is, as long as k is not 0. So let me show you. For example, if I make k any number except 0, 2. If I solve this, or if I graph it, how many roots should it have? Should have 2. You can't quite see here. Well, you can kind of see here. It has 2. Doesn't matter what I make k equal to, as long as I'm not making it equal to 0. So 102. And then if I graph this, you see again. Again, 2 roots. And one more, what about if I do something like a negative? So if I say sub k is minus 1, 2, 3. Again, 2 roots. So no matter what the value of k, you've shown that this quadratic always has 2 roots. What happens when I make k equal 0 though? What happens to the graph?
3. Just line.
Not quite, almost. So if I make k 0, it's not a quadratic anymore, is it?
Linear.
It's linear, yeah. So you get this, and this only has 1 root, but you're not allowed to use that because we said it's a quadratic. So what do you think happens if I make k really close to 0? Is it still a quadratic? Yeah, because it's not 0. But it should kind of look linear, almost. Let's see what happens. Now, you might think, wait a second, that's a straight line. But was k equal to 0?
No.
No, so it should still be a quadratic. So let's zoom out. Ah. Yeah. So k was not 0, so it's still a quadratic, which means it has 2 roots still. But it doesn't look like it has 2 roots here, does it?
Yeah.
No, it looks like it has 1 root. But we have proven and guaranteed that it'll have 2 roots. It's just you have to go really far to find the second one. Yeah? Nice? Yes. Okay, so we'll do a couple of more examples of a different type now. The next type, we're kind of going backwards. So I tell you how many roots it has, and you want to know what the k was. Okay, so for example, fix. Nope. Oh, I broke it. No, I fixed it. Right. So find how many roots this has. Minus k plus 4 x squared plus 2k minus, sorry, not find how many roots, plus, or
Can you write
minus
like
k
a bit
minus-
down and calculate?
oh yeah, there now. Yeah. This quadratic has 1 root. So I'm telling you that this quadratic has 1 root and you want to find k. Alright, let's do this one together. So if it has, oh, and I should also say we know one thing about k. I'll put on the ceiling here. K is not equal to, k is not equal to, not in this case actually, 4. Because you don't want this part 0. Alright. So if it has only 1 root, what do we know about this? It should equal 0. Okay, let's try and find the k. So b squared minus 4ac should equal 0. By the way, I don't think I said this. I think people know it though. There's a quick way to open this. Ax squared plus 2abx plus b squared. But if you don't like remembering things, you can just do it like this, as I showed you. Anyways, that's not too important. Back to the main event. So here, I open this and I get 4k squared minus 8k plus 4 minus 4, and now we'll multiply these two together. That's k squared, let's see, minus 4k plus k minus 3k minus 4. 4k squared minus 8k plus 4 minus 4k squared plus 12k plus 16. Now this is nice. I did this on purpose so that the k squareds cancel. So we have 12k minus 8k is 4k. 4 plus 16 is 20. So that means 4k equals minus 20. So then k equals minus 5. So this is the value of k that makes this have only one root. Okay, let's do another one like this. Can I scroll down? Yeah. Okay. One a little bit more difficult. So this one here, minus 9k. Oh, hang on, no. Oh no, it's okay. Minus 9k minus 9x squared plus 6k plus 6x minus k has two roots. Maybe we'll just lower this switch. No, that's worse. Well, don't touch it.
Excuse me, can you go back a little bit?
To the original? The previous one?
Yeah.
Yeah, just for a second then. Here. Yeah. Okay. Let's have a look at the next one now. Have you got this one?
Yeah.
You look confused. No? Ah, I wonder who this is.
Leon.
You think so? Ah, what happened to you? You got lost. You got badly lost, so that's okay. There's a seat over there, it's easy for you to sit at. So which was it? Wrong bus? Wrong classroom? Which problem was it? Huh? Both? Oh, that's bad. Okay. Can I go to the next example now? Yep, okay. So this here has two roots. So we know that the discriminant should be bigger than 0. We also know that k should not equal what? Yeah, shouldn't equal minus 1. Okay, let's see what we can say. B squared minus 4ac should be positive. 36k squared plus 72k plus 36 minus 4, 9k squared plus 9k should be bigger than 0. 36k squared plus 72k plus 36 minus 36k squared minus 36k should be bigger than 0. And again, it's not an accident. I made the question so that these will cancel to make it easier. 72k minus 36k, 36k plus 36 must be bigger than 0. So then that means 36k must be bigger than minus 36. Yeah, so k must be bigger than minus 1. Okay. Of course, this is all you can say. K must be bigger than minus 1. You can't find the exact value of k, but this is the answer anyways. So again, what I want to do is I want to make the graph for this, and I want to put in different values of k. So if I make k bigger than minus 1, I should have two roots. If I make k equal to minus 1, it should be linear. And then what if I don't make k bigger than minus 1? What if I make k smaller than minus 1? Then it will only have, I think it will only have, and maybe it'll have no roots actually. Yeah, 0 roots, yeah. Let's have a look at the graph. Okay. Right, what was the quadratic?
Minus 9k.
Yeah.
Minus 9. 6k.
Yeah.
Plus 6.
Plus 6x minus k. Alright, so give me a what do I want? I want a number that is bigger than minus 1. Okay. So give me any number bigger than minus 1. 0 is bigger than minus 1, yeah. Okay, so if I graph this, I should get a quadratic with 2 roots, which I do. Okay, and give me another number bigger than minus 1 for k, so 1, for example, is bigger than minus 1. So again, if I graph this, see it also has 2 roots. Now, let's see what happens if I don't have a number bigger than minus 1. If I have a number smaller than minus 1, what do we think happens? Some people are thinking it has no roots.
Linear.
Yeah, linear is at minus 1.
Yeah.
I'm using minus 2 for this one. Let's see what we get. So it has only 1 root. Okay. Or maybe it has 2.
Maybe it had two.
I did?
Yeah.
Oh, I did. I put in
Yeah.
I put in x. Alright, let's try that again. Minus 2 for k. Graph. There it is. Can you see it in green? No roots. And then lastly, we're not supposed to use k as minus 1 because then it has only, well then it has 1 root, but it's a linear, so we're not really supposed to use it. Oh my goodness, it has no roots. See it in purple here? Let's
Yeah.
zoom out.
It's y equal, yeah.
Let's see what happens if I put k
Y
group.
equal 1.
Ah, it's a horizontal line.
Yeah.
Yeah.
Because this is gone.
This
Yeah.
is down.
This is gone. Yeah. So it's just horizontal then. Alright, that's weird. Okay.
Minus 2 is also quadratic.
Yeah, it's this one in green. Can you kind of see that?
Yeah.
But it has no roots here. These red one and blue one, when I used values of k which are bigger than minus 1, so when I use 0 and 1 and 2 and 3, this will make a quadratic with 2 roots. If I don't use this, I won't get a quadratic with 2 roots. So we can see I got a quadratic with no roots. What did I use to get this one? Minus 2, was it? Yeah. And this one here isn't even quadratic when I used minus 1. It's linear. Okay. Remember at the start we said we can't have this because we don't want this 0. Yeah, you don't want this part 0. Okay, did you write this one down? Yeah. Okay, I think I'll give you the questions and you can try them for a few minutes. For the exam, usually, I don't know why, but usually in the exam, this question, it's usually like number 3. There's 1, 2, 3. And I think the reason is number 1 and number 2 are too easy for the exam. So there's only number 3, sorry. So I know number 3 is a bit difficult. Now, even though, wait just 1 second actually, even though this question might not be in the exam, it's still useful because, for example, you could have a question like this. And the question might say, sketch. And you might think, okay, so the first thing I'll do is I'll try and find the roots. But of course, before you should try to find the roots, you should check to see how many roots there are. So a quick check, and you see that you'll get 36 minus 40, which is minus 4, which is less than 0. So that means no roots. So you shouldn't try to find the roots when you want to draw this. What should you try and find? Well, you can find the y-intercept. What's that here? Yeah, what number? 10. And what's the other point I should find?
The roots.
No, I can't find the roots, no roots. Turning point here. So you can see very quickly that it'll be x plus 3 squared plus 1. Yeah, so this point here is the point... no, I did it the wrong way around. It should be going to the left, like this. Because here is minus 3, 1. So you can see very quickly I have a sketch of the graph. I know where it is and what shape it is. Okay. So even though this question might not be on the exam like this is still a useful formula to have, especially for the questions we did last time, the sketching and the drawing. Okay. Let me mark which ones to do. So in number 1, we can say GHI. And then in number 2 can be XYZ. And then, yeah. And then, in the last one, number 3, where's it gone? LMN. And D. Sorry, DLMN. DLMN. Yeah. Okay, you can do these for a few minutes. You'll have enough time to get question. You should get question 1 and 2 finished before you have to go. I mean, it won't take you more than 5 minutes to do those. Question 3 will take you a little longer. There you go.